I think you just like forgot it. I don't think you were really saying that equal that. I think it must have just checked the box and moved on.
Wow.
Keep in mind that 3 to the negative 2 is not negative 9. That's a 9 in the denominator. You can go over that one if you want.
Three can go into 12. Oh. No, we don't. If you don't get a glass, the 4 is not X student. We have our exact as the greatest common factor, and then so that makes it 3x to the second.
So like this.
We don't have the first. We have the first base. We have the opposite. This is
And end up with a negative number. Because the exponent means, it doesn't mean like, let's multiply the exponent times base. It means how many times I can itself. And so when somebody sees 3 to the negative 2, I think a lot of times what they think of is they say, oh, 3 squared is 9. Oh, and the negative means make the base negative.
So does this become
Squared.
Yeah. I like to think of it like this. That negative means flip the base to the other level. So I'm going to do that first. So I would say this is the same as 1 over 3 squared. I like to do it in that order. I don't know. You could make it 9 to the negative 1 and then flip it, but I think it makes more sense. Yep.
The fact that they would tell you that you're in it and then like cut.
Okay, what questions can I answer for you all? Say again? Say one more time. I was just asking if you had any questions.
Oh, okay.
Yeah. Guys, do you have any questions at all? Okay, so
Yeah, number 1.
number 1. You want to talk about number 1?
Yeah, I do.
Okay.
I love that.
So number 1, before you start solving anything, we want to simplify as much as we can. So simplify before we try to solve. So do you see the distributive property in there?
Yep.
That 5. So I'm going to distribute the 5. That gives me 5x minus 5 plus 7 equals 11 minus 3x. Make sense? I see a real easy simplification on the left. Negative 5 plus 7 is positive 2. And it feels like I'm done simplifying here, but I'm not quite done because there is a variable on both sides. There's an x on both sides. And so I could either subtract the 5x over to the right side, or I could add the 3x over to the left side. I would suggest adding the 3x over. Fewer negatives to me is always good. So plus 3x to both sides would give me 8x plus 2 is equal to 11. Still doing okay? Now I've got to get rid of the 8 and the 2. I could go in any order, but I feel like it'd be easiest to get rid of the 2 before I got rid of the 8. So I would go minus 2 from both sides. This gives me 8x equals 9. And then I would divide both sides by 8. This would give me x equals 9 over 8. That'd be the solution. That'd be the one number that makes that equation true. Yeah. Did I answer your question okay? Is that just seeing it there? Is that good?
Yeah.
Okay. I can tell. You can see. All right. What else can I do for you guys? Colton. 4, sure. So I think there are 2 paths to success on 4. And maybe I'll show you both. Based on what you guys have been doing, I think either one of these would work great. So here is way number 1. Way number 1. Maybe I see factoring as the way to go. Whenever you're going to factor anything for any reason, really, you have to factor what first? What's in common? They both have a 5, and they both have an x. Does that make sense? So I'd factor out the 5x. I'd be left with x squared minus 4. So, is that okay? Now, I don't know how you would factor this, but we always want to check to see if the leftover stuff in the parentheses could be factored again, a little bit deeper. And this one can. Let's look at it. Like this. Go for a box, and x squared would go there, minus 4 would go there. What's my AC? Which numbers multiply to be negative 4 and add to be 0? Negative 2 and 2. So negative 2 and 2, so it'd go negative 2x and 2x. And then I'd factor just like I always do. So from right to left there would be an x in common. And then from right to left there would be a 2 in common. And then factoring up, there's a 2 in common, but it's got to be negative 2, right? Because of the negative finishing box. And here there's a common x. So there's my factoring. So I could then try to squeeze this in. 5x times x minus 2 times x plus 2 is equal to 0. And then I use the 0 factor property. So this would be 5x equals 0, x minus 2 equals 0, x plus 2 equals 0. So when I divide by 5, I get this. When I add 2 to both sides, I get that. Finally, when I subtract 2 to both sides, I get that. There's another way. What if I started off factoring? Let's say that I got to this stage and I said 5x times x squared minus 4 equals 0. And I thought, why not try, maybe it'll work, maybe it won't. Why not try to set each factor equal to 0 now? Because I did just factor, didn't I? So how about this? 5x equals 0, x squared minus 4 equals 0. So over here I divide both sides by 5 just like I did a second ago. I get x equals 0. And on the right side, maybe for the first time I notice the b is 0, right? Whenever the b is 0, what method can I use? The square root thingy, the square root property, right? So what I would do is I would get the squared quantity all by itself by adding the 4 to 0, adding the 4 to both sides. And then I would square root both sides. I'd get x is equal to not just 2, got to consider both positive and negative roots. So I'd say in this case, the square roots was faster, right? So you guys remember the analogy of the little jeweler's hammer versus the sledgehammer? This is a nice side-by-side comparison, right? On the left side is more of the sledgehammer. We're just going to make this thing work, and we made it work. Wasn't too hard. Sledgehammer worked okay. You see how the right side is much quicker because we use the right tool for the job. Done. A couple of taps of the right tool and we're all done. Same answers. Colton, good, bad?
Good.
Good? Okay. Good, Karen.
Okay, so I didn't completely different in both of these. And
Let's hear it. What'd you do?
I added, so I took the x out.
What do you mean took it? Oh, you factored it out?
Yeah, just the x though.
Okay, so let me just kind of follow along with you. X factored out, so it'd be 5x squared minus 20.
Yeah, and then I added 20 to the other side.
So, okay, we might have a little issue here, at least the way that it's written. So if I add 20 to both sides, right?
Yeah.
So if I go plus 20 plus 20, 0 plus 20 is 20. No disputing that. On the left side, I think we have an issue simply because which term on the left side is like the plus 20? Yeah, so I agree with you, but the way that it's currently, think of it like this. Let me write it horizontally. That might be helpful. If I just rewrote what you said, check that out.
Yeah.
Do you see, like if I showed you just that left side and said, hey, let's simplify this, what would be your first move? You maybe subtract it back over. Would kind of get you back to square one, right?
Yeah.
If you didn't do that, like let's say that you realize that Chase is like, well, that doesn't make any sense. Let's not do that. So we said, hey, let's just only focus on the left side. We got that equals 20 over there, and I said, let's just look at the left side. Let's combine some like terms if possible. What would you do first? Okay, you could take out the 5, or you could could you redistribute the x maybe?
Yeah.
Or something, we'd be stuck in this limbo, and you'd find that there are actually no like terms with the 20 on the left side.
Yeah.
Does that make sense?
I just didn't add it to both sides of this, because then I divided by 5 and I got 4x squared equals x squared equals 4.
Whoa, okay, hold on. Let's hear this. So you just sort of ignored this.
Yeah.
Okay. So I just want to kind of explore with what you were thinking. Equals 20. Then what'd you do?
So I did it because I added the 20 to the other side. I just didn't have it. That's why I made it wrong.
This just disappeared?
Yeah.
Be careful with that. Be careful. Yeah, if something just disappears because you're like, you shouldn't be there. Think that through. So then how did this proceed? So
So I divided by 5.
So, okay, so you basically, I get it. Well, okay, here's something interesting. So you divided both sides by 5. Now we're going to do the same thing to both sides, right? Whatever happened with this?
I don't know. I just put it as 0.
Just cause.
Yep.
Yeah, so be really careful with the communication. And so here's where there's a big trap for all algebra students. Listen, the big trap is doing things and not knowing why. Does that make sense? Like following a procedure, maybe a halfway good, halfway bad procedure, because man, we do add stuff to both sides. We do divide things on both sides and all that stuff. What I would encourage you to think about is this: the big concept with an equation, you must maintain balance, right? You've all seen it, like in middle school. An equation is a balance, and whatever you do to one side, you've got to do the same thing to the other side. Stop and ask yourself, is what I'm doing really making sense? And if the answer is yes, proceed. It might be right or wrong. Just be careful. It's interesting as I ask you those questions, you're like you're like, yeah, that's what I did. Almost like you're self-incriminating. Bless you. Like, yeah, that doesn't make any sense. Okay, do you see what I'm getting at? So slow down and think, is what I'm doing making sense? And if it doesn't, get help. Ask me, and we'll get you on the right track. Does this help? Has this been helpful? Okay. So I would say, you've taken good elements and sort of kind of patched them together, and in the end you got a miraculous 0, and I would say the communication is pretty not so good. Does that help? Okay. Anybody else? Thanks for asking, Kyrie. So every now and then, I will say this, to your credit, every now and then somebody will say, hey, I did it this very different way. What do you think? It's brilliant, or it's good, or it's medium, or it's bad. And I'd put yours in the medium category because you had some good elements in there, but communication was all messed up, right? But every now and then, so I say don't hesitate. If you ever feel that way, I tried it this different way, it could be a great way, and it might help somebody else in your class to see it in a different way, and that's awesome. No problem. Anybody else? Let me ask you one last thing then. Did anybody Anybody struggle at all with 2? And in particular, did anybody struggle with what to do with that? So let me just give you a quick refresher on how to handle exponents like that and bases like that. So check this out. Let's see if this makes sense to you. Would you all agree with this? And if something doesn't make sense, tell me. Here we go. I'm just simplifying. Kind of a first step. So far, so good? Yes, you said yeah? Okay. Times, I'm going to go in the reverse order here. Okay with that? All right. You okay with that? You okay with that? What I see a lot of people do is this. They want to, and I think this is where a classic case, you've heard this for years, where teachers say, math teachers in particular, don't skip steps, right? Sometimes it's perceived as, hey, we're just trying to make your life as difficult as possible, blah, 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 right? That's not the case. So how many of you really wanted to just automatically make this a 16? Some of you, yeah? How many of you wanted to automatically simplify this? This is where you run into issues. As I walked around, I saw a lot of folks write this. So 3 to the negative 2 is definitely not that. And this is why I would suggest don't skip steps. You'll see here in a second. So here we go. So if I start off with this, maybe I go and I start to simplify a little bit. 4 squared. Maybe let's hold off on all the numerical bases. Let's look at the variables first. If I've got those two, what is that, when I combine those, what does that end up being? X to the negative 20. Yep, we add our exponents in that case. And then how about the y's? Y to the 4th. Okay. I still have 4 squared. I still have 3 to the negative 2. And this might be a good time to do this. Remember, negative exponents have a very specific meaning. They tell us to take the base and do what? Yeah, flip it. Flip it to the other level. Do a reciprocal is really what we're talking about. So if that base is in the top, flip it to the bottom. If that base is in the bottom, you flip it to the top. There's only 2 possibilities, and you just move it to the other one, right? So, 4. What kind of exponent? So leave it, right? X. What kind of exponent? Ooh, so we need to move that one. So here's my fraction bar. 4 gets to stay right where it is, but that x has to go. It's got to flip down, so it'd be x to the positive 20 down below. The y, what kind of exponent? Positive, so it stays right where it is. That's just what that means. So it'd be y to the 4th up there. And then the last one, the one that we struggle with the most, 3 to the negative 2. We so desperately want to turn this into a negative 9. It's not what it is. Not what it is. Negative exponent, right? So what do we do with the base? Flip it down. So it'd become 3 to the positive 2 down there. So as I fully simplify this and finish it out, now I feel comfortable saying 4 squared, yep, that's 16. 3 squared is 9, x to the 20th. So instead of saying that 3 to the negative 2 is negative 9, what's a better way of saying it? 3 to the negative 2 is really 1/9, right? It's 9 flipped down. So just a word of encouragement to you. Don't simplify these too early. Don't skip a step. It might save you a little bit of hassle and frustration by just keeping it real simple at the start there and then flipping up and down as required.
In the future, let's say like instead of 16 it was 15 and like 9 and 15 have a common factor. Could we simplify that way too?
Yep.
Okay.
Agreed. Okay, fantastic. If you guys would, flip ahead in your notes. We're going to do one short example here today. Introduce something sort of new, maybe not to all of you, but here we go. Would you please take a minute and explore this lovely quadratic equation. See if you can solve it using any method. Not so good with this. First of all, is the b 0? Now, if you look at that standard form of a quadratic, we've got ax squared plus bx plus c equals 0. What's the a value?
3.
What's the b? It's not 0, so we can't use the square roots property that we did before. And c is what? -1. Okay. So solve using any method. So we can't use the square roots method. How did this factor for you?
Not so,
It didn't factor at all, did it?
just the ones are prime.
Yeah, well, and the 5 is an issue, the 3. I mean, it's just the number combination is just not right. I don't know if any of you tried to complete the square like we did last time, but you'd find that the fact that the a is 3 really complicates complete the square. We could actually navigate it. It would be doable, but it would be some pretty ugly numbers and fractions for a while, and if we can avoid that, let's avoid that. And so would it be fair to say that what you just experienced has convinced you that all the methods we've learned up to this point maybe are the wrong tools for this job? Perhaps there's another tool in the shed or the garage that would work a little bit better. Some of you know it. Do you know what it's called? The quadratic formula. Is that what you were going to say?
No.
Ava, what were you going to say?
I got an answer. It was most likely wrong.
Okay. Well, we can explore that here in a second. Let me show this, and I'll be happy to look at your answer here in a second. So some things that would be worth noticing about this quadratic equation. What do you guys think? What are some things you notice? AX squared. Well, ax squared plus bx plus c. I'm just talking about the standard form.
A equals 0.
A equals 0.
No, I just said the equation.
Oh, gotcha. Yeah, so this right here. So I'm going to say standard form, where you've got everything on one side equals 0. That make sense? What else do you notice about the left side?
There's no what do you call it, terms or variables?
There are no like terms, agreed. And those unlike terms go in what order? Descending order. Okay, so guys, this is really important because anytime you've got a formula, the success or failure of the formula depends greatly on getting all the right things in the right places, doesn't it? If you've got this formula, think of it like this. What's the area formula for a circle? A equals doesn't it involve a pi?
I know that.
Area of a circle, pi
Diameter or radius?
pi r squared. That's a formula, isn't it? So think of it like this. If I've got area equals pi r squared, and I plug the diameter in for r,
It's not right.
I got an issue, don't I? I plugged the wrong thing in for the radius, right? So here's the deal. This quadratic formula thing is awesome, and it works great. But its success or failure completely hinges on, have you correctly identified the A, the B, and the C? If you misidentify the A, the B, and the C, I don't care how cool the quadratic formula is. There's even lots of songs that go along with it. Have you heard them?
Yep.
I don't really care how cool all that is. If you plug in the wrong things, you're gonna not succeed, right? It's gonna be failure. And so it's really important that in order to use this quadratic formula, your quadratic has to be in standard form, and it's got to be in descending order. So you got to have everything on one side of the equation equals 0, and all that stuff on the left side has to be in descending order of degree. So 2, 1, 0. That make sense? So I'm going to leave you with this. I'll leave you with the quadratic formula, and we'll do our concept quiz here in a second. But I'll leave you with this, and we'll practice the quadratic formula in the coming days and weeks. So here we go. And maybe we'll even sing a song. Here we go. You ever seen this before?
Oh yeah, holy nards.
You ever seen that before?
Yes. You've also kind of snuck it in some of our houses.
Oh, someone was paying attention. I have snuck this in. I have snuck bits and pieces of this into your homeworks and your concept quizzes and your review quizzes all year long. Have you ever seen this before?
Yeah.
It's been all over the place in your homeworks, DMR quizzes, stuff like that. We've even done this a little bit, except without the plus or minus. And once or twice, we even did the whole thing without the plus or minus, just with like a plus or something, or just a minus.
That's crazy.
So you've actually been doing this all year, sort of. You just didn't know exactly maybe what it was, but you've been practicing this all year. Just debating about this. I kind of want to call a little audible here. Yeah, I think what I want to do is this. You're supposed to have a concept quiz today, and we could fit it in right now, but I think I want to do it tomorrow. So, hey, listen, what I want to do at this time is I want to do one of these here with you. That make sense? So I'll leave you in a better place. But before we do an example, listen up. You might, I hear a couple of you, kind of like let out this, whoa. As I wrote that up, they're like, whoa, that's sort of scary looking, right? So a couple words about that. Number one, you will not get a formula sheet for this, or a cheat sheet, or it will not be supplied to you. One of our takeaways from Algebra 1, as you move into like geometry, Algebra 2, we've decided, I think it's pretty well founded, you need to know the quadratic formula. Makes sense? As you graduate from Algebra 1, you really need to know the quadratic formula. For some people, memorization of this will be easy. Others, it'll be tough. I get that. Bless you. So there's a song. How many of you have heard the Pop Goes the Weasel version of this? So let's do this. We're going to sing this together. Can we hum or like sort of just sing the tune of Pop Goes the Weasel? Like da-dun, 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 da-dun. Yeah, right? Okay, you ready? Let's do this together. No sitting there doing nothing or you're going to get a solo. Okay? Ready? At the very least, mouth the sounds. All right? Ready, set, go. Da-dun, 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 da-dun. Pop goes the weasel. Okay. It's great when you play that with little kids. Like my little son, he just when you're cranking the little crank, we have one of those Pop Goes the Weasels. Like he is so pumped to watch that thing pop out. He's just like shaking, and then it pops out and he freaks out. Okay. So, does anybody know the quadratic formula words that go along with that tune? Yes? So will a couple of you sing with me? This will help you remember this. Ready? So join in. These guys will maybe help me. Ready, set, go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, that was awesome. That was pretty good. Yes, well done. Well done. And that was recorded. Hopefully forever. At least until YouTube crashes or something. Who knows? Okay. So let's practice this again. Hey, let's practice this again, except instead of just like 3 or 4 of us, let's get a lot more of us, okay? Ready, set, go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Good job. Now, if you're super curious, there's like 30 different versions, probably more than that. I've identified like 20, 30 different versions on YouTube of people like rapping this, singing, all these different, some tunes I know, some tunes I don't know, all these different ways. So listen, you find one that works for you, and if you want to sit there during our quiz or test on this sort of thing later on and like kind of rap it out or something, I don't care. As long as you've got a way for you to learn this and memorize this, that's great. So, how is this applied? As was mentioned earlier, I think this can look pretty familiar. So check this out. Number 2, says solve, simplify your answer completely. So here's what you might do. You might look at this and say, oh, I know how to do this. I'll just factor it. A couple minutes later, you're going to say, I don't know if I can factor this. This does not seem to be going well. So we ditch factoring. And then you say, oh, I could do the square roots thing, right? Because that worked well. What's wrong with that? Why can't I do square roots? B is
5, not 0.
B is 4, not 0. Maybe you think about complete the square, but I have a feeling that you are going to very quickly shift your affections towards the quadratic formula versus complete the square. So in order to complete the square, we have to be in standard form, descending order. Are we in right now standard form, descending order? We are. Yeah, it's 5x squared plus 4x minus 2. Everything's equal on one side equal to 0. Descending order. I think we're in a good place. Let's identify, what do you guys think the A value is? 5. What do you guys think the B value is?
4.
And the C? -2. Be really careful that the sign in front of the number goes with the number when we do this. All that's left now is to use the quadratic formula. X equals -b plus... Get it all filled in, all right? So here we go. Make sense? Wherever I see an A, I'm putting a 5. Wherever I see a B, I'm putting a 4. Wherever I see a C, I'm putting a -2. Once you guys have gotten to this point, see if you can simplify this down. Simplify it as much as possible. There are a few things, a few tricky steps along the way. See if you can simplify it. That's a good answer. But we're going to try to evaluate this down to the simplest possible form. So keep in mind, with your quadratic formula here, it's x equals -b plus or minus the square root of b squared is what this should be. B squared. And so that'll make this 4 squared. And it's minus 4ac.
No, maybe to put it in, for the plus and to put it in.
It's positive 4 squared, right? Because your b is 4. It should be positive 4
They can't
squared.
give you 2 answers.
Does that make sense? Were you thinking that because this was negative, this had to be negative? Possibly? Say again?
Because that one was negative.
No, it's positive b squared.
Where do you go after?
Make sense? Okay. How's it going? What's that right there?
Right here
No,
or right here?
this symbol right there.
That is a 10.
A 10. Okay, gotcha.
Yeah.
Keep going, Victoria. It looks pretty good so far. Uh-oh.
Wait, when you get back.
Wait, do we need to simplify the roots like completely?
Yeah. Yep. Hey guys, let's wrap this up. You guys will get, gosh, like 3 or 4 days to work with this. Yeah, gosh, probably 3 or 4 days to work with this next week. This will be just a little bit of a warm up here. So here we go. X equals -4 plus or minus the square root. 4 squared is 16. And sometimes people will struggle with this part. If there's ever a struggle, it's usually that part right there. I'm going to look at this as -4 times 5, which is -20. And -20 times -2 would be a positive. So it's going to be plus 40. All over 2a. 2 times 5 is 10. If I keep going, I get x is equal to -4 plus or minus square root of 56 over 10. And that's a pretty good answer right there, except that root 56 can and should be simplified. So if you use your factor tree stuff, you're going to get 2 root 14 for that root 56. And then the last piece of the puzzle is, do you see how both terms in the top have a common factor of 2? Common factor of 2.
Yep.
So we could say this, we could factor out a 2. You see how I factored out a 2? Where's the minus? Oh, I lost a minus. Sorry. Every now and then my palm, so Apple Pencil has palm reject, and every now and then it doesn't reject my palm. And I think I wrote something and I didn't. Thank you for pointing that out, because it should be there. Then, do you guys see how this 2 would cancel with that 10? Like it would reduce down to be a 5?
Yep.
And a 1? So it'd be x is equal to -2 plus or minus the square root of 14 over 5. You can imagine now why this didn't factor. You can imagine now why complete the square maybe would not have worked so well. Imagine some of these things, right? So like I said, you'll get a little bit of practicing on this today, but then our big focus of next week, kind of the whole week, is going to be the quadratic formula. So anyways, the rest of this week is all about reviewing and preparing for your test on Thursday. Hope you guys have a great day. See you tomorrow.